So welcome student in online lectures on your topic phase equilibria. So today we will see the last point from your topic, that is three component system. Similarly, as we have seen in one component, two component system, for three component system, again the phase rule will be modified. Okay, as we know that how the degree of freedoms can can be calculated. That is F is equal to C minus P plus 2. As in this system, three components are present. Then overall, the modified phase equation will be for degree of freedom F is equal to 5 minus P. If we consider minimum number of phases as 1, okay, that is P is equal to 1, then to represent three component system, 4 degrees of freedom, that is 4 variables like pressure, temperature, composition of two components will be required. Okay, but graphical representation with 4 variables is quite impossible. So so that purpose, or because of that reason, two variables, pressure and temperature, are kept constant, and hence reduced phase rule for three component system will be F is equal to 3 minus P. So this will be the modified phase rule phase rule equation for the calculation of degrees of freedom when the system is of three components. Now let us see how the graphical representation for this ternary system can be done. Okay, so most general method used for graphical representation of ternary system is triangular plot, which was suggested by initially Stokes and Rosebaum. In this method, variation of composition of three components at constant pressure and temperature are expressed by means of a equilateral triangle. Okay, each apex, or we can say of the each corner of the triangle is taken as 100% of each component. Okay, it may be 100% weight or 100% mole percent. Okay, so how it can be represented, you can see here a triangle in which as generally we have seen the phase diagram involves a simple plot. Okay, a two-dimensional plot in which x-axis and y-axis is present. So, and for x-axis we give temperature or pressure as a parameter for x and y-axis. But here, as temperature and pressure as kept constant, uh, we only deal with composition and the respective component, and that's why, as there are three components are present, a triangular type phase diagram will be the best solution for the representation of such ternary system. So you can see here apices A, B, and C. These corners of a triangle A, B, and C indicates 100% of respective component. It is A 100%, B 100%, and C 100% at each apex of the triangle. Again, each side of triangle is divided into 10 or sometimes 100 equal parts, and the lines parallel to three sides are drawn. Okay, so you can say each side of triangle is divided into 10 parts. That is as per the percentage 10, 20, 30, 40 up to 100%. Similarly, each side, this AC, AB, or BC, each side of triangle is divided into 10 parts. But in some cases where we need some more elaboration, then we can divide this into 100 times. That means each point on this side will indicate it by 1%. Okay, as we know that we can draw any graph. Okay, or like a graph paper. Then we have to draw the lines parallel to each side. That is, if we consider this 10% of AB side, this point, and we joining the 90% point on the AC side. Okay, this line is parallel to BC. Similarly, this line, this point 10% from AB side and the 90% on BC side is parallel to side of triangle is C side of triangle. In such a way, again we have to draw the parallel line to AB. In this way, we will get such type of triangular phase diagram. All these parallel lines will divide each side at particular point. Okay, if we take a parallel line, okay, this is at 10%, parallel line to AC will divide the side AB, okay, at this point, which is indicated by 10%. Similarly, any point on any side of triangle refers to the binary system representing composition of two components in the system. Okay, for example, if we take any point, okay, let us see. If we take this point X, okay, if we take the point X, which is situated on AC, okay, side AC, what it indicates, that is, this side indicates the percentage of A, this side of triangle indicates percentage of B, and this BC side indicates percentage of C. So at point X, you can say easily 30% of A is present, and if we see this parallel line, okay, that is parallel BC line, which cross at this point on BC, which indicates 70% of C. Okay, if we take point Y, then it indicates 60% of B, and the same time 70% if we go in this way on BC, 60% Y, 40% C. Okay, similarly, if we take Z, okay, Z here 50% of B and 50% of C. Okay, right? 50% of B and 50% of A. Anytime. Okay, we can take it also 50% of A and 50% of C. Okay, so if we take on the sides, okay, any point on any side of the triangle, any point on any side, okay, if we take the side that is at point this Z point, which indicates the percentage of C particularly, then if we go through on side BC, then we get the percentage of B. If we go on point side AC, we get the percentage of A. Okay, so any point of on side, okay, side of triangle gives the binary system. That means composition of two components. Okay, while any point in the triangle, okay, any point in triangle represents composition of all three components. Okay, that is inside the triangle, within the triangle. If we take this point F, okay, if we consider the point F in within this triangle, area of triangle, then this point is not on a side, but it is in between, inside the triangle, so it indicates composition of all three components. Okay, so from this point we got 50% of B, 50% of A, and lastly, sorry, 50% of A, here you can see 50% of A, and then 20%, okay, 20% of B, and 30%, 30% of C. Okay, so in this way we can determine any point in the triangle. So in this way we will see one of the system in which acetic acid, chloroform, and water are present and they are in equilibrium. So how what will be its phase diagram? As we know that acidic acid and water are miscible with each other, similarly acetic acid and chloroform are miscible with each other, but water and chloroform are not miscible, or we can say slightly miscible in each other. Okay, then if as we know that if we add water to chloroform, they will form two layers as they are not miscible to each other. So this type of system involves one pair of partially miscible liquids generally. Okay, one pair, that means chloroform and water are partially miscible liquids, but acetic acid is miscible in both the solvent. Okay, that is both chloroform as well as in water. So in this case, acetic acid acts as a medium, and which which is able or acts as a catalyst to miscibilize chloroform and water layers. Okay, so let us see how the diagram, a phase diagram of this system will be plotted. If we add very small amount of water. Okay. First thing, here in this triangle you can see at apex, this A point we have acetic acid, in this point we have chloroform, and at this point we have water. Okay, so if we add at all these apexes, 100% of each component is present respectively. If we add small amount of water to chloroform, a homogeneous solution is obtained because water and chloroform are slightly miscible. Okay, if we add very small amount, then we cannot differentiate two layers. Okay, we found that only a homogeneous solution is formed. So in that case, it is found that a homogeneous layer is formed. But if as we increase the amount of water, the mixture separates out in two layers. Okay, so one containing solution of chloroform in water, and another layer contains solution of water in chloroform. Now if we add acetic acid to this mixture, then the acetic acid distributes between two layers and it increases the miscibility of water and chloroform into each other, because acetic acid is soluble in both the solvent. Okay, so how much amount of acetic acid we will add to the solution, that means in which two layers are formed, then some part of acetic acid will dissolve into chloroform, and some part of the acetic acid will dissolve into water. In this way, some part of water layer and some part of chloroform layer will get miscivilized into each other. Okay, so got the point. So in this case, acetic acid acts as a medium or acts as a catalyst which can increase the miscibility of two immiscible layers. There is chloroform layer and water layer will be get miscibilized by using such type of like acetic acid type of mediums. If sufficient amount of acetic acid is added, then two layers emerge into clear solution, forming one layer containing all three liquids. Okay, a particular, that is a sufficient amount of acetic acid will create a situation in which both the chloroform and water layers will get miscibilized into each other, which form only one layer. Now let us see what this phase diagram will say. The points A and B, point A and B in the figure represents the composition of two layers when water and chloroform are mixed. Okay, when water and chloroform are mixed, this A indicates chloroform into water, and B indicates water into chloroform. On adding acetic acid to this mixture, the composition of these layers changes from A B to A1 B1. Okay, so there may be change in composition we will observe. The line joining A1 to B1, that is line joining A1 to B1, is called as tie line. That is the straight line A1 B1 through C1. A1 B1 through, at this point the composition of this mixture will be C1. Okay, there is optimum concentration we can call as C. This at this point the composition will be C1. At this point it is will be C2. Okay, and at this point C3. That is the straight line from A1 to B1 which going through C1 connects the composition of two layers in equilibrium, and this line is called as tie line. As more amount of acetic acid is added, the solubility of two liquids increases and the tie lines A1B1, then A2B2 and A3B3 becomes smaller and smaller and finally reduces to point D. That means the composition, as we know, if we add chloroform into water or water into chloroform, if we take at point A, okay, if we take at point A, let us consider 10% of chloroform and 90% of water. Okay, they form two layers. At the same time, if we take at this point, then here 10% of water and 90% of chloroform, then when we try to add, okay, when we start to add acetic acid, this composition, okay, the mixture or the layer will again these two layers will going to form a homogeneous layer, that is will result reduces into one layer when the composition, when the mixture or the way the amount of acetic acid with increasing amounts we are adding, then at point certain point at point D, all these, that is both the layers CH3, that is chloroform and water layer at point D are acts as a homogeneous layer. The composition of two layers changes from A1B1 to A2B2 and finally A3B3, and overall composition changes to C2 C3 along the dashed line AC. Okay, AC is the total composition. Okay, optimized composition. At the point D, the compositions of two layers becomes identical and two layers merge into a single phase. It is one layer. This point D is called as isothermal critical point. Above the curve ADB, that is, if you consider this curve A, D, and B, above this curve, the system becomes bivariant. The point C, okay, the point C represent the overall composition of the mixture. Overall composition of the mixture. From this overall discussion, we can say that mixture of three liquids following overall composition within dome-shaped area. This is like dome-shaped area ADB. Will have two layers. Okay, within this layer, within this area, chloroform and water are two layers are formed. Okay, and mixture in the region outside this area, that is within this triangle but outside this area, is the remaining area of triangle, will have only one homogeneous layer of three liquids. Okay, so within this dome two layers are formed, two layers are present, and above this layer only one homogeneous layer is present. The curve ADB, this ADB is called as binodal curve. So this is simple, we can say simple diagram, phase diagram of acetic acid, chloroform and water as a three component system. So this is about a three component system. I will stop here, and this is about three component system.